Hi everyone, welcome back. In part 2 of this week's video, we're going to build on the example we started where we created this spaceship here that we can control with the arrow keys or spacebar. Okay. By the way, fun fact, p5play works when you say left, up, and right. Also work with the ASDW keys at the same time, so good to know. So we're going to build on this little example that we started, and we're going to turn it into this video into more of a fully functional game, which means we're going to add game states. We're going to talk about adding the asteroids object and do the collisions with the ship, with the lasers. While doing so, we're going to set up collision functions specifically, which we haven't done in the other example we've built. And at the end, we'll add just some few finishing touches with some sound effects. We'll add a health bar to represent how much health our player has left. And yeah, so we'll build a little bit more complex game mechanics than we did for the zombie apocalypse example. So let's just get right into it. So just to start off, I've basically cloned the where we left off in the previous video into a new example. And we are going to start by adding the asteroids into the game before we can get into having game states and game mechanics. So just like with the other p5play objects, sprites that we have over here, we are going to define a group for the asteroids. So let's call this group asteroids. We'll make it into a global variable. I like to make these into variables so that if we need to refer to them at different point in our game, we're able to do that, access those different sprites, those different groups through these variables. Then once we've defined our variable here, we're going to go and create it in setup. So after we've made all of these game objects, let's go down here and let's make our asteroids, and that's going to be a new group. All right. Okay, so the asteroids, it's going to be a new group. They're going to treat them as circles, basically. So we'll say asteroids dot diameter equals, we'll give them a random diameter, again, using the arrow setter to set a random diameter. Or actually, maybe we won't do that. Let's see. Because we're going to attach images to the asteroids. So let's start there. So we have our asteroid.png here in our assets. So we're going to go in preload. We're going to say, let's create an image. Let's call it asteroid image. We're going to go in preload. We'll say asteroid image equals load image asteroid.png. Okay? And then once we've done this, we're going to go into asteroids here when we create the group, and we'll say asteroids.image equals asteroid image. Okay? All right. And just so we can test here, we're going to go and right away, we'll say asteroids.amount, we'll say equals 10. Okay, so we're going to just create 10 of them right off the bat. And something happened here. Asteroid image not defined. Yes, because I've called it asteroid img. My bad. Let's call this the proper name. And let's go ahead. Okay, so p5play, when we create the asteroids, they are just all overlap over one another right now, and you can see they get separated out as we've seen before. We're also going to turn on the debug mode. Always helpful to have that on when we're developing, just so we can see what's happening with the shape of our asteroid, the shape of our object here. Okay, so let's start setting some attributes of our asteroid group. First is maybe we're going to set their location to be random. Okay, so we'll say let's give them a random location, and I'll say random with asteroids y equals random height. And anytime we have these dynamic attributes, right, we always want to use this syntax here, the arrow setters. Okay, so now they've been scattered all around. That looks a little bit better. We're also going to give them, let's give them a direction and a speed. Let's see what happens if I set a diameter of 50. So even though I've attached an image now, by default, the collider became a box. But if I set a diameter, now you can see the collider, right, is now this circle. So what we're going to do is we're going to look at the size of our asteroid image, and we're going to use that, the width of the image, we're going to use that as the diameter of our collider. And now we can bump into these asteroids, or if we shoot them with our lasers, right, they're going to get knocked out. Boom, boom, boom. Just we can tweak that a bit. Let's say we're going to make 80% of the width just to make this circle a little bit tighter. Okay, that looks good. All right, so now we have a pretty good approximation of our asteroid sprite image. So that looks pretty good. Okay. So in addition to randomizing where they start, we may want to also give them a speed, right? So when we create the asteroids, let's go and give them a speed. Let's randomize that as well. Some of them will be faster than others. So now they all move to the right. Let's also, before we give them a speed, why don't we give them a random direction also? Again, always using the arrow setter. We're going to say random 360. So they could be starting off in any direction. Okay. All right, so this is a good starting point to test with. We have our asteroids. We create 10 of them using the amount feature of the group. And they are knocking our ship here a little bit. Okay, interesting. We seem to be caught in a forever rotation loop, but we're going to fix that. We're going to fix that eventually. Actually, let's address that right now. One thing that can happen is, let's try again. Oh, my bad. So one thing that can happen here, wait, what did I do? Group, save, hit play, is as we get hit by these asteroids, they're going to add a certain amount of rotation to our ship. And we have drag for the movement, but we don't have any amount of drag for the rotation of the ship. So if an asteroid hits us pretty hard, it can be difficult to snap out of that rotation. So what we're going to do, just to fix this right now before we move any further, in addition to having general drag, we're going to add a little bit of rotation drag to the ship as well, so that if we do get knocked out, eventually our ship will be able to recover. The rotation will slow down just like the motion of our ship slows down right now. So this applies resistance to rotation as well. Okay, so we have our asteroids. Now, one thing that happens is they're getting scattered very quickly, right? And they're just leaving off the screen. So just like we did with the ship, we are going to implement this behavior where when an asteroid leaves the screen, we're going to make it come back on the other side. So we only have the same 10 asteroids that we have to shoot down. And in this weird universe that we're in, where the world is actually a donut and everything wraps around on all sides. So this is going to be the same thing as we're doing with the ship. We're going to apply this idea to the asteroids. So instead of repeating ourselves here, what we're going to do is we're going to take a moment to create a little function that will say, if you have a sprite object, right? This could be the ship, this could be an asteroid. The logic is the same. If you have a sprite object and its coordinate is less, right, than half of its size, okay, then you can wrap its position, move it around. So we're going to create this into a reusable function that we can apply both to the ship and to the asteroids. So let's go below here and let's make a function. We'll call this function wrap around, I guess. That's a good name. Well, if that makes sense, we'll say wrap around, and the input to the function is going to be a sprite. Okay. So this could be any sprite. And we're going to take this code that we're doing right now with the ship. I'm going to paste it down into my function just to save on some typing. And we are going to replace ship with sprite. Okay. I'm going to do a little bit of manual replacement here. It's probably some more effective way of doing this, but for now, it will do. So just make sure that you catch all of the mentions of the ship, okay? Because otherwise we don't want this function to affect our ship while we're using it on asteroids. And now what we could do if we wanted to apply this behavior to one of our game object, we could say wrap around ship. Okay? So now our ship is continuing to wrap around. Okay? But because we've made this into a reusable function, we can also say apply asteroid behaviors. We're going to say use a for loop. We're going to iterate through all the asteroids that we have. Let's say A of asteroids. Okay. And we'll use A for short to refer to individual asteroids. So we're going to iterate through our for loop, and we're going to say wrap around A. So now this is going to apply the behavior, or if we want it to be, we could also use the full word, okay? Just if it's confusing. Now we're going to apply the behavior to the asteroids as well as the ship. So they are also now going to wrap around. And if I knock them out, they come back. Okay? So that's going to make our game a little bit more fun, because now we have to be a bit cautious. It's kind of a risk-reward thing. If we shoot an asteroid, there's a chance that it's going to come back around and maybe hit us in the back. So we have to be a bit more strategic about how we position our ship and before we start shooting everywhere. Okay. All right. Okay. So this is our basic game objects. Now let's talk about now from here. There's a few ways that we could go, right? We could start to implement game states. Before we do this, we can probably work a little bit more on our game logic, right? Should be careful here to stay away from these crazy asteroids. We can implement a little bit more of our game logic, perhaps. So what we're going to do is we're going to create a collision between our lasers and the asteroids. And we're going to make it so that our asteroids are going to have a certain amount of health. And every time we shoot them, they're going to shrink. And eventually they're going to get small enough that they're just going to get removed from the list. And this is how our ship is able to destroy these asteroids over time. So let's set up a collision function. So let's go into setup here. I'm inside setup. Now, by the way, we're starting to have a lot of functions in our code. We have preload. Our code is getting longer. Let's move the console down so we can see a little bit more of it. Now is usually a good time where I suggest starting to also create. I used to, just little delimiters like this can be helpful, especially as we're working in a basic editor like the p5JS web editor. We're going to start to create some visual separation between our functions. I find that helps a lot as I'm scrolling through to see where things begin, where things end. Okay? And now we can go back to setup over here, and we're going to say, let's define our collision between the asteroids and the lasers. So we can do this from the perspective of any of the objects. So we'll do it from the perspective of the asteroids. So we'll say asteroids that collides. We'll say lasers. So here we're saying take this group of objects, and whenever it collides with an object from that group, we're going to define a function that we want to run, an event. So we'll call this function asteroid hit. Okay, so this is when we're going to know that the asteroid has been hit by a laser. Okay, so this function is a function that we haven't written yet. We're going to go do that right now. So asteroid hit here, we just made it up. So I'm going to go down to the bottom. We'll say function asteroid hit. And then the parameters to that function are going to be the asteroid that was just hit and the laser. And the order in which they are defined depends on which perspective we define the event from. So here I did it from the perspective of the asteroids. So that means asteroids collides with lasers. When we define our event, we'll have the asteroid is going to come first and then the laser. So here we can have a little console.log just to see that it does something. I'm going to move the console up a little bit. Let's keep our delimiters going and let's hit play. Okay. Oh, can't see the console, it's too small. Okay, so you can see now whenever I successfully hit one of the asteroids, I got this text here that gets printed, and I was able to successfully hit them 7 times. Okay. Pretty slick. All right. So let's figure out what we're going to do when an asteroid gets hit. Okay. The first thing we might want to do is we're going to tell the laser we're going to remove that laser object. Okay. So that if we shoot an asteroid, that laser shouldn't continue. It's going to get deleted. So you can see it's hitting the asteroid and our laser disappears as soon as we shoot it. So that might be step 1. Okay. The other thing we're going to do is we're going to shrink the asteroids based on how much life do they have. Okay? Now, how do we give our asteroids life? Well, it's very simple. These objects, right? The sprite objects, we can create any attribute that we want on them that doesn't already exist for something else in p5play. Okay? For example, if I want to say the asteroids are going to have a certain amount of health, I can just go and create a health variable on my asteroids. Okay, we can just add as many attributes as we want. Let's say it's going to take 5 hits before we kill an asteroid. We're going to give our asteroid 5 health. Okay. So we can add attributes onto our respective game sprites based on the needs of our game. Okay? And we can have as many as we want. So now my asteroids have something called health, which means that when we hit the asteroid, now we could say asteroid.health. Maybe we take off 1 health. Okay. And then we're going to use this health value that we have to change the size of the asteroid. Okay. So let's make a variable here. I'm going to call it h. We're going to map the asteroid health. So the asteroid health we know is going to be between 0 and 5. Right? Let's map this to a scale factor for our sprite. So let's go between 0.2 and 1. And then we're going to use that to set the scale of our sprite. Okay? And you'll see what happens when I hit the sprites now. When I hit the asteroids. So every time I hit an asteroid now, it's losing health, okay? And it's getting smaller. Okay? So we're mapping its health now to its scale, and every time we hit it, it updates the scale of the object, and it's starting to get smaller. Okay? Now, at some point, we want to look for the condition when the health is going to reach 0. Okay? Because otherwise, we're going to end up with asteroids with a negative scale eventually. I don't actually know what that does. Just going to probably look really strange. So we want to be able to take an asteroid out when its health has reached 0. Okay? So we're going to check for that as well in our asteroid hit collision. We'll say if asteroid.health is, let's say, lesser or equal to 0. I always like to use lesser or equal to just in case. I know we're only taking off 1 here, but you never know. If we change the amount of health down the road, like this is a safe thing to do, we'll say asteroid.remove as well. Okay? So let's see if we can have some good aim here and try to delete some asteroids from our game. Okay? So this is a little tricky to record a video and talk and play at the same time, but I'm going to try to do my best to see if we can get some of those cleared out. So as they get smaller, of course, they're getting harder to hit. And, we don't want the game to be too easy. And eventually, some of, here, why don't I just try a strategy here where I'm just going to shoot everything. Oh, geez, I gotta be a little bit careful. So that's part of the design of this game. See, I got some of the little ones here. And now that when their health reaches 0, they just disappear. Okay? And we don't add any more asteroids over time. We just have our amount of 10 to begin with. And so the goal of the game now just becomes carefully navigating this field and making sure that we don't get hit too much while we try to destroy all the asteroids. Okay, so you kind of get the idea. What are these tiny little circles floating around? Are they small asteroids? That doesn't look right. Oh, I said move. I meant to write remove. Okay, sorry about that. So this should be remove. And I'm not going to try to defeat them again. That was actually pretty hard. But you'll see. Well, let's just, again, we'll use the same tactic. This game is harder than it looks. Now we should actually be able to remove the asteroids once they reach 20% scale. Yeah, I can see I'm deleting some of them now. And over time, I'm going to get rid of all of them. Okay. All right, so this is how, just to kind of recap here briefly what we just did. right? We created a collision function between two of our game objects. Here we're able to respond to the collision. I'm going to get rid of this console log before I forget. We don't need to spam the console here necessarily, but that's a good way to know if it's just working. So collision functions we can define between any two game objects in p5play or any two categories of game objects, right? So both the asteroids and the lasers are groups, which means they actually represent multiple objects. And as soon as any two members of those groups collide with one another, we get to run this particular function. So let's go ahead and we're going to apply the same idea here to our spaceship. We also want to lose health whenever an asteroid collides with our spaceship. So let's go on our ship here and we're going to say ship's going to have a bit more health than the asteroids. To be fair, we're going to give our ship 10 health to begin with. Again, this is a variable we're just making up. It's not part of p5play. We're just adding on to what's already there on the sprite object, and we can add any number of variables or attributes that we want. And here we're going to define a collision function for when the asteroids collide with the ship, and we're going to call this function ship hit. Let's go down here. Okay. Let's make another function. We'll call it ship hit, and asteroid will come first because that's the group that we set the collider on, and then the second parameter will be the ship. All right. So ship hit will say if, right? We'll say if the health of our ship is greater than 0, we're going to take down 1 health. Okay. And then eventually here we're going to have this is where we're going to be able to trigger the game over state, right? Once we find that the ship's health reaches 0. Okay. We'll put a little note for ourselves here. Eventually trigger game over state here. We can't do that just yet because we haven't put in place the game state infrastructure just yet. But now we have this variable on our ship that is called health. We could do a console log if we wanted to. We could say ship.health just so we see what happens. And every time we get hit, okay, why do I get undefined? Oops. Let's go back and see if I did a typo. So ship should have a variable called health. Ship.health minus minus. Sorry about that. Okay. So I did a typo here. I meant to say ship.health. Hopefully you caught that as I was talking. So now when we get hit by a asteroid, we can see that it's going to log in the console our remaining health. So I'm going to purposefully crash into some asteroids now just to see, and we're going down to 6, 3, 2, 1, and then finally 0. And we won't be able to go any further than 0 because we have this if statement preventing us from doing that. All right. So there's I got to stop using the ASWD keys to control the ship. It's convenient, but it causes me to accidentally type stuff into the code that I don't intend to. All right, so let's get rid of this console log. So now it would be nice if we could represent the amount of health our ship has. So we could, if we wanted to, the easiest thing is we could just write some text that would say health, and that health would go down. But just for fun, we're going to draw a health bar. Okay. So a health bar is simply just going to be a rectangle that we set the size of based on how much health we have. And again, we can use the map function to help us do that. So let's go into a draw function here, and we're going to draw our little ship's health bar. And we'll do that at the end here after everything else. Okay, so draw the ship's health bar. Okay. So let's figure out here, we're going to come up with the width of a box, right? Based on how much health we have. So let's call this variable health width. And we're going to map the ship's health, which we know goes from 0 to 10 in the game. Let's map this to, let's say, 0 to 200. Okay? Then we'll set a red fill. And let's draw a rectangle at 2020 using health width and 20 tall. Okay? So when we have maximum health, right? We're going to have this bar is going to be full. And as I get hit, this bar is going to shrink. Okay. Now, just so if we wanted to, one cool thing we could do also is we'll just set the stroke here to white, and we'll set no fill, and we'll draw the full rectangle, 200, 220. Turn off the stroke again for other things afterwards, so that as we lose health here, right, we can see how much we've lost just because we have the 200 rectangle showing us how much we've lost, showing us the total health we could have. Now you'll notice the asteroids and the ship, they all appear on top of our health bar, which is kind of annoying because that's because in p5play by default, right, all the sprites are drawn automatically, and we're about to take manual control over this because the next thing we want to talk about are going to be this idea of game states. Okay, now that we have our mechanics in place, okay, we have our asteroids, we have our ship, we can control it, we can shoot at the asteroids, and we can destroy them when they get small enough. Okay, pretty nice. And what we need to add to this to really turn this into a game is the sense of progression. In other words, we're going to start with an intro screen, and then we'll start playing. And if we run out of health, we'll go to a game over screen. And if we win, we'll go to a victory screen, and we'll give the chance for the player to try again or play again if they want to. Okay? So we'll add the flow of the game. This is the thing that we're missing now. Okay, so we've talked about this in the other game example that we've done. The idea here is we need to be able to have draw do different things at different times, right? In other words, when I first hit the play button, instead of just jumping right into the game, I want to maybe present a title screen and wait for the player to click something before moving on to the next stage. So we need to be able to do different things inside draw. And the way we can do this is simply create sub functions that we will then call into draw. Will alternate between different functions depending on what we want draw to be doing. So currently, all the code that we have right now, we can think of it as this is the code that is running the game. Okay? So we're going to take that code out. I'm going to cut it out. So everything that was into draw here, and we're going to put it in its own function. We'll say function run game. Paste that down here. And let's go and put a little divider here also. So now this is what happens when we want to run the game. Okay, so we could now go into draw and we could say run game, right? So this is a review of what we've done before, but it's still important to talk about these game states. Now, if we wanted to have a different screen, a different state happening in our game, we could just simply define a new function for that state. So let's work on our intro screen. Now the intro screen, will keep it very simple in this game. Just again, I made a where is it? Title. What is it called? Title screen. Okay. Just some AI generated image here that we're going to use as our title screen. And so let's go into the sketch. We're going to start by loading the image. So let's say we're going to call this title image. Then in preload, we'll say title image equals load image title screen dot WebP. It's just a different format here. Okay. And then once we have this, we're going to go and create a intro. So I'm going all the way to the bottom here. We're going to put our line divider, and we'll say function intro. And all the intro is going to do is draw this image, the title image, at 0, 0, and you want it to fill the width and height of the screen. And we're going to say just do that for now. Okay. So now if we were to call this instead, okay, instead of run game into draw, let's comment this out for a second. We're going to call intro. Okay. It's going to look like this. Okay. So now we can see we have our image being drawn, but we're still seeing our game objects. Okay. And again, that's because by default, p5play has 3 things happening behind the scenes. It draws all the game objects, it updates all of the game's internal attributes, and then it steps through the physics simulation through this world object. So we're going to turn off the automatic mode on all 3 of these so that we can decide when we want to do different things. So in the intro screen, for example, we don't want to do anything. We just want to show the intro image. And then once we actually run the game, we want to be able to run the simulation and so forth, and then draw our game objects. So here we're going to go into setup, right? So I'm into the setup function. I'm going to go at the end of setup after we just, where we have some space, and we are going to say, tell all sprites dot auto draw, turn that off. We'll set it to false. All sprites dot auto update. We'll also set that to false. And then the world, which is responsible for doing the physics, auto step, we'll set that to false as well. So now these things that used to happen automatically behind the scenes, they've now been set to false. So if I hit play, now we're in Asteroids and nothing happens. Okay? We're seeing our title screen and we're not seeing any of the game objects. Nothing is going on. All right. Okay. So let's move on. So the what we need to do now is we need to have the ability to switch, right, between these two states into draw. So we want to only ever run one of these functions at a time. One way that we've done this in Zombie Apocalypse is we created a global variable called game state. Okay, we said game state, and we made it say equal to intro. And then in draw, we had some if statements that said if game state equals intro, run the intro, else if game state equals run game, run the game portion. Okay, so we had this kind of structure in Zombie Apocalypse, which works fine. In this example, I'm gonna show you another way that we could approach setting the game state, which will be, instead of setting a string and putting that into game state and then using an if statement to check the string, we are going to set game state directly equal to one of our functions. So if I say game state equals to intro, not in quotes, this essentially makes game state the same as our intro function, right? So now we have our intro function now has kind of two names. We can use intro, and if we say game state and call that as a function, it's going to call the intro code. Okay. So now we can go into draw and we can simply say game state. Okay. So whatever we've made game state equal to, right, runs whatever we made game state equal to. So whatever we made game state equal to, this is what's going to run. Okay. So if we wanted to switch the game state using this model, all we would have to do is we would go into, let's say, go into our intro here. We're going to say if keyboard.presses, oh no, actually we said if mouse.presses, we said click to start. So we're going to say game state equals run game. So we're not using a string here. We're just making this equal to the function itself. Okay? So that when we click, it's going to move into run game. Now notice we see our health bar, but we don't see any of our game objects that we expect to see, and that's because we have turned that off, right? We said in setup, all of this automatic game object stuff is now turned off. So in run game, we have to draw our game objects by explicitly telling the engine to run those drawings. So we could do this anywhere. Here, I'm going to do it right before I draw my health bar. Okay, and here, instead of, I copied and pasted this just to make it a little bit quicker. We'll say draw, update, and step. Okay, these are the three things here. So this is show the p5play sprites and animate them. Okay. Put a little comment. So this is going to draw the sprites, update them, step through the physics, and then this is going to draw our health bar on top. So now, now we have the health bar actually on top of our objects. Well, we can't see it anymore, but if I could just fly over that portion of the screen, the ship is now behind, right, and the asteroids as well. So we can use this not only to control like when, if in certain states, if we want to draw the objects or not, but we can also control when we're doing the drawing. So if we want to draw our sprites at a certain time, and then draw other things on top of it, like a user interface, for example, we now have specific control over the timing of when these different tasks occur. Okay. All right. So now we can step from the intro into the run game. Okay. Why don't we turn off the debug at this point, so we can just look at our game a little bit. We'll turn that off, set it to false. This is what our game looks like now. It looks a little bit better. So let's detect the case now when we're going to trigger our two other game states. Okay? So what are the two other game states for this game? Well, we have either a victory condition or a lose condition, right? So when we run out of health, we're going to be game over, and if we somehow miraculously end up destroying all the asteroids, and believe me, I've done it before, it can be done, it's not that difficult, we'll have a victory screen. So let's go in and create some more game states. So down here, we're going to make another function. We're going to call this one game over. So this game over function is going to be what runs when the game is over. So we'll say, let's set our black background here. We're going to make that function not too fancy. Okay, we're going to draw all the sprites, but we're not going to update or animate them. So this is going to give us this kind of like freeze frame effect where we'll see where everything is, but we are not going to move them or step through the physics. And then in game over, let's go and do some text here. We could get fancy. We could bring in special fonts. We could have an image that we display. Here we just want to show that we can go to this other game state. So we'll get a little bit lazy here and then just draw some text. Okay, we'll say game over and then put that in the center, maybe a little bit to the top, and then below we will say press S to try again. And I'm going to use a specific key as opposed to just clicking or spacebar, just so we don't accidentally go through it. Actually, if I'm playing with ASD, I could accidentally start over again. So maybe we will use a different key here. We'll say press T to start again, or R to start again, whatever. Okay. So we could check here if the keyboard presses, if the key pressed is R, then we can start again, and we'll say game state equals run game, and we'll say let's put our ship back in the center of the screen, bring our health back to 10, and then we're gonna get rid of all the asteroids that we had, and then immediately make 10 more. Okay, so this is going to be our game over state. Now we need to be able to trigger this game over state when we run out of health. So let's look for the part in the code when we run out of health. So that happens when the ship gets hit over here. So here we had put a little note that said eventually we'll trigger the game over state when health reaches 0. So here we'll say game state equals game over. And again, I don't need to make this equal to a string now, because now we're calling game state itself as a function into draw. So our draw function is even simpler now. We just say whatever game state is, this is what you're going to run. Let's test it. So I'm going to, on purpose, get run over by these asteroids. I need to run out of health. Now we're down to 0, and okay, some text appears. It looks a little bit wrong. Oh, I meant to do text size here. Sorry about that. Text size 40. That should look a little bit better. Let's try it again. I'm just going to crash into these guys. Okay. Game over. Why is it overlapping? Oh, because I put -50 for both of them. So one of them will go slightly above the middle. The other one will go slightly below. All right. This shouldn't be very difficult. Let's, okay. Game over, press R to try again. Okay. Nothing fancy. We could maybe put a little black rectangle behind this, because this is a little bit hard to read. So let's try and do that. Maybe I'll set a black fill that's semi-transparent, no stroke, and let's do a rectangle here. We're going into the weeds here a little bit. Anyway, Let's not do that. Well, I'm gonna also have to change the rectangle mode for a health bar if I do this. Let's just leave it. Okay, but you could imagine any kinds of, you could draw an image here on top, maybe something that's a bit easier to read. Um, no big deal. Or maybe we'll set a black stroke. Is that gonna affect the text? Might make it a little bit easier to read. But again, this is a, oh yeah, now we can see a bit better perhaps. Anyway, not important. All right, so now we have a game over. We have a game over screen, and we haven't tested restarting the game, so let's do that. I'm gonna get crushed by these asteroids here. And if I now press any other key but R, nothing happens. But if I do go and press the R key, this is gonna start over again. Now you may have noticed I got hit by a asteroid right away in the beginning because when they spawn, just like with zombie apocalypse, where is the asteroid? Over here. They just appear anywhere. Okay, so that's kind of annoying. It could spawn right on top of our ship. So what we're going to do here, just to fix that, because our asteroids wrap around the screen, we're going to spawn them off with negative numbers, between 0 and negative numbers, so that they're going to appear somewhere on the left or somewhere on the top. And because of if that happens and their direction, right, they're going to automatically get wrapped to the other side, and eventually it's going to look like they're coming from all angles. So see, now they all appear off screen, and then they are slowly coming in because of our wraparound behavior. And if we die, okay, then if we press to try again, you see that we're not going to get accidentally crushed by some asteroids right away, which is, kind of unfair to the player. So just a little tweak here, not necessary, but just as you develop your game projects, right, you're going to discover things as you play them, and you can tweak the mechanics as you go, as it makes sense. Oh, shoot. I thought I was controlling my ship, and I was just mashing random keys in the editor. All right. Okay, so let's also implement a victory state here. This one is going to look a lot like the game over state, so I'm going to, for simplicity, I'm just going to copy and paste this function. Okay, and we're going to call this one victory. And in the victory state, the difference is we're going to change the text. We'll say, "You are safe. Good job." And then we're going to put the same text below, press R to try again. The only difference here is basically the when it comes time to restarting the game, we don't really need to worry about removing all the asteroids because the assumption is that they've all been destroyed already. Okay? And then we're going to trigger this game state when we remove the last of the asteroids. So that happens in our asteroid hit event, right? Over here, if an asteroid health was less than 0, we remove it. And then we could do is we could add another little if statement, another little check that would say if we ran out of asteroids at this point, okay, we're going to say if asteroids.length equals 0, means we don't have any more asteroids. We're going to say game state equals victory. Okay. So if that was the last asteroid, we win. All right, now you're just gonna have to take my word for it that this game can be won. I'm not gonna try to beat it here on camera. This is maybe for a separate video, but try it for yourself. You'll see that if you destroy all the asteroids, you'll be able to reach that victory screen. Okay. All right. And now finally, just as a little final touch, I thought we would talk about adding some, what did I do here? Adding some sound effects, right? So we'll add some sound effects to our game just because I have them. They're not super amazing sound effects. I got them from a free sound effect site. Link will be in the comments. So let's just load these sounds and we'll talk about, instead of just having background music like we did in the previous example, we will have some sound effects we can trigger. So we're going to make a few global variables here. I have 3 different sounds. I have a crash sound for when the ship is going to hit an asteroid. I have a smaller kind of chipping away at hit sound from when the laser is going to hit the asteroid. And I have a sound for the laser getting fired itself. And you could have any number of those, of course. So we'll have a sound effects for the laser, a crash sound effects, just so we know when the player, like in addition to the visual of the health bar going down, we'll also have an audio cue when we get hit by an asteroid, and little hit sound effects as well. So just like with the images, we're going to load these in preload because we want to make sure these files are fully ready to go before it's time to use them. So this is laser.wave, and I also have crash sound effects. This one is called crash.wave, and I have a hit sound effects, which is called hit.wave, I think. Yep. Okay. All right, so this is going to load our sounds, and the P5 sound object is pretty straightforward. Whenever you want to play a sound, you just hit play. We're not going to make them loop like the background music. So let's say when we fire our laser, let's go into our run game function. When we fire the laser here, we're going to say laser sound effects dot play. Let's test that. Just going to put on some headphones here so I can hear, make sure it works. Now we have a laser sound. It's a little bit loud, so we could either edit the sounds and make them quieter, or in setup, we could also say output volume. We'll set that to 0.5, so it's a little quieter. So this is kind of like a master volume for our entire game. And we could also, let's add the other sounds. So whenever we have an asteroid being hit, we're going to say asteroid, we're going to say hit sound effects dot play. And whenever the ship gets hit, we're going to play the crash sound effects. So just for fun. Oh, something happened here. Accidentally put an extra D. That crash sound effect sounds pretty brutal. And we have a smaller one here that shows when we successfully hit an asteroid. And sadly we lost. Okay. All right, so this is pretty much it for this this one game example. Now, really briefly, I also wanted to talk about kind of circle back to the canvas, which we mentioned in the beginning. We said we use this pixelated mode canvas. Okay? And what it does is it allows you to create these sort of scale independent games. And so, for example, if we made the canvas smaller here, let's say we're going to go to 600 by 600, okay? We could make the whole game feel bigger, right? So now we have fewer pixels to work with, and the size of this canvas is going to remain even if we go in full screen, right? If I go and share this and look at the full screen version of the game, it's still going to create a square canvas that's going to have this internal size of 600 by 600. Sorry, the crashing sound is annoying. 600 by 600, and it's going to create this pixelated effect look. So let's go back here and make it equal to 800 again. So this is what the pixelated mode can do. You can also use it to create like a much smaller world and then zoom. So if you say pixelated, let's say ×2, it's going to give us kind of a zoom version of our space. Okay, so it has some cool features, but we'll just use the regular pixelated mode here. So now it guarantees that my game window is essentially 800 by 800 regardless of the screen resolution, which means all the tweaking that I'm going to do for my object speeds, my object sizes, relative distances, things like that, it's going to be a little bit more consistent than if the size of the game all of a sudden changed based on the browser window. Okay. Yeah, so that's one benefit of using the canvas object versus the regular p5.js canvas. Okay, so we'll leave it at that for this week's example. I hope you enjoyed this tutorial, and I'll see you next time.